This lab used everyday objects to demonstrate fundamental principles of electromagnetism. This lab specifically was about inducing a charge in neutral matter and quantifying that charge, as well as its implications on the physical behavior of subatomic particles within neutral matter. The two pieces of tape were originally neutral matter that were then induced and had a positive charge. They were then used to induce other charges in neutral matter which they were attracted to, and because the tapes repelled, the charge could be calculated by comparing the force of the charge of one tape on another to the force of gravity experienced by the tape. The fundamental principles involved include conservation of energy and Newton's second and third laws of motion, as well as the concept of charges and induction of neutral matter. The results suggest that the tape had a deficiency of 5.02 times 10 to the negative 8 power electrons for every atom, resulting in a net positive charge. Also, the results corroborated the idea of charge and repulsion between like charges and attraction to oppositely charged matter, as well as neutral matter via induction. The data collected is as follows. The length of the first tape, which was used to repel the bridge, was 0.2 meters. The length of the second tape, which was used as the bridge, was 0.214 meters. Therefore, because the density of the tape was approximately 1 gram per meter, the mass of the second tape used as the bridge was 0.0214 kilograms. The distance d between the two tapes at which the force of electrostatic repulsion first acted was 0.018 meters. Using this information, the charge of the tape Q was found to be 2.5 times 10 to the negative 7 coulombs. The ratio of electron deficiency to atoms was 5.02 times 10 to the negative 8 electrons deficient per atom. Here shown are some observations and calculations taken. It was observed that U tapes would be attracted to random neutral matter, however they were repelled to one another. It was then determined that the tape was positively charged, it will attract, and if negatively charged, it will repel. Neutral tape would have no effect or weak attraction to the pin. Therefore, it was determined that because the positively charged tape was attracted to the negatively charged pin, the tape itself was positively charged. Here, a free body diagram is shown to demonstrate that the force of gravity was approximately equal to the force of electrostatic repulsion between the tapes. Here, the charge Q for the tapes was calculated using the free body diagram shown earlier, as well as Newton's laws of motion and conservation of energy. Here, the electron deficiency per atom was calculated, knowing that the tape held a positive charge and knowing the Q charge of the tape found previously. Shown here is the glow script code modeling the experiment. The two tapes are represented by blue spheres, which makes the assumption that they are point masses acting on it alone in space. The force of gravity is shown in gray, and the force of electrostatic repulsion that each tape experiences from the other is represented in green. Note that the electrostatic repulsion points in the opposite direction of the other piece of tape. If electrons and protons had their charges swapped, there would result no change in observation of the experiment, because the charges of the tape would still be the same and would therefore repel each other, and the charges of the neutral matter that the tape stuck to would be opposite of what was used to induce it, the tape, and therefore it would still stick to neutral matter. It was imperative to keep the tape out of contact with conductive matter such as other tape, or especially human hands, as it would allow excess electrons to flow to the tape and diminish the positive charge held by the tape.